The overall goal of this synthesis and purification is to relatively easily produce a Ruthenium-360 analog used in mitochondrial calcium uptake assays that is 10 times more effective than commercially available Ruthenium-360.
This method can help answer key questions in the field of mitochondrial calcium biology by providing a pure inhibitor of mitochondrial calcium uptake. The main advantage of this technique is that the final product is both very potent and pure. Individuals new to this method may struggle because purification requires time and patience. Demonstrating the procedure will be Sarah Nathan, a graduate student from my laboratory.
Begin this procedure with synthesis of pentaamine chlororuthenium dichloride as described in the text protocol. Dissolve 100 mg of pentaamine chlororuthenium dichloride in 50 ml of 1 molar ammonium hydroxide solution in a 200 ml round-bottom flask. Loosely cap the flask with a glass stopper and heat the reaction mixture at 75 degrees Celsius for 6 hours. Heating a sealed vessel results in a pressure buildup. Make sure the glass stopper is loose to allow release of excess pressure. After 6 hours, remove the reaction mixture from the heat and stir at room temperature for 4 days to yield a dark green solution. To purify the resulting trans-diaqua-octaamine mu-oxo-diruthenium pentachloride by cation exchange chromatography, first suspend 5 grams of mesh cation exchange resin in 10 milliliters of 0.1 molar HCl in a 25 milliliter beaker. Load this slurry into